Hello everyone, this is Don with MecSoft Support, and in this video we're going to be taking a look at VisualCam Express. Express is our entry-level CAM plugin for VisualCAD. So we're going to run VisualCAD and drag this over. And initially, if you're watching this, you may not have a VisualCam license yet. So when VisualCAD CAM loads for the first time, it'll come up with this dialog and allows you to do a couple of things. You can run FreeMill, which is our free milling plugin. However, it is free, but it is somewhat limited. You can run the CAM demo, and when you get your license activation code, you can activate your product here. So we're going to run the CAM demo, and from this dialog, from the mill module, you have different modules that you can run. From the mill module, we're going to select the Express configuration and then pick mill. Okay, so VisualCAD CAM displays, and this dialog on your left is actually the VisualCAM plugin, so let's turn that off just for a second. So right here we're looking at VisualCAD. This is a free CAD program that you can download anytime and use it with no restrictions. And I'll just give a really brief run through of what you can do in VisualCAD. Up here we got a ribbon bar. We got the home ribbon bar where you can do your file maintenance commands, open, save as template, print, etc. And then you have a plugins pane where you can manage your various MecSoft plugins. And you see VisualCam here as one of those plugins that are currently loaded. And then, of course, you have your options. You can control all aspects of your drawing inside VisualCAD. Okay, so this display tab, you can modify your view, pan, rotate, those types of commands. You can orient your display, right view, front view, etc. And then you can change your display type, your mode, shaded, wireframe, etc. And you can control the visibility of your construction planes, viewports, etc. And then we have a modeling aids tab, which will you can help by selecting things. You can filter, mask, or filter different selections. You can lock and unlock various geometries, control your construction plane, and then also you can set up a background image if you want. We also have an extensive curve modeling set where you can draw a multitude of curve types and also curve editing tools as well. We also have a surface modeling tab where you can do basic surface modeling and editing. The same for basic solids in editing and meshes in editing. And you can also dimension your drawing and perform analysis. And then also in the active viewport, you have viewport commands, zoom controls, undo, redo of different zoom orientations. And then down at the bottom here, you have your status bar, displays your coordinate of the cursor, your units, and then also object snaps for snapping to different types of objects. You got your properties manager and your layers manager, and you can pin those to the sidebar. As you see, here's the properties manager and here's the layer manager. Okay, let's go ahead and open the part for this short demonstration. And we already have it loaded up here in our recent documents. And what we have here is a mechanical, somewhat prismatic part in that you have straight walls, you have pockets and holes, things of that nature, and you do have some curvature around here that we're going to use some 3-axis strategies to machine. Okay. So let's also, you can change the viewport if you want to do multiple views, you can take a look at it in multiple views. So we're going to do one ISO view, and then let's go ahead and load the mill module. So we'll go to the Home tab, drop down the VisualCam menu, and pick Mill. And this is the milling module, where you have the machining browser here at the top and the machining objects browser here below. And let's go ahead and load a tool library real quick. We'll load our inch library. So we got 56 tools loaded. Okay, so let's go ahead and do some express machining on this part. So we're going to run through the basics of setting up this part for machining. We're going to start at the Program tab and work our way from left to right. We're going to define the machine, and in the Express configuration, the number of axes is one option for 3-axis, and that's the same for both 2- and 3-axis machining jobs. Okay, next we're going to set up our post processor. We're going to select Post, and here you can see that you can set your current post processor. We'll just go ahead and set that to a Haas controller here, and we'll just skip down here. We're going to use a NC extension, and you can add additional extensions if you like. Pick OK there. So we got our machine set to 3-axis, our post set to Haas. Now, the next item on the machine setup portion of the Program tab is to orient your part. When you open your part, if it's not oriented the way you want it for machining, you can use this command and you can automatically orient your part based on the direction that you want to machine. So our part is already oriented how we want it to be machined on the machine bed. So we're going to go over to the stock command. So in the Express configuration, you have 2 stock types. You have a box stock and a part box stock. The difference being is that in the box stock, you can give it the exact dimensions of the stock that you wish. Okay, we have our machine and our post defined. If your part doesn't load in the correct orientation that you want it for machining, meaning the Z-axis direction for the spindle, you can use the orient part command and actually automatically move your part around in different orientations. But our part is oriented the way we want it, so we're going to skip that. And then we'll go over to the stock menu. And in the Express configuration, you have 2 stock types, a box stock and a part box stock. Now, the box stock type is you can just load, define the length, width, and height of your exact box that you want to use. In the part box stock, you can use the extents of the part, and then you can add material in the X, in the Y, and the Z. So we're going to use a box stock, and we're going to select a copy model bounding box, and that's going to tell you the exact dimensions of your part. So our part's about 2 inches long, a little over 2 inches wide, and a little over 3/4 of an inch high. So we're going to do copy model bounding box, and then we're going to set this, the length we're going to set to 2.25, and the width we'll set to 2.25, and then the height we'll set that to 1 inch. So that's going to be the size of our box stock, and we'll pick OK. And there's icons here at the bottom of the machining browser where you can turn off various items, and we defined our stock, so now we can turn that box stock on, and you see that we currently have a bitmap image display. So let's turn that off. Okay, so here is our box stock, and let's go over to the preferences and let's change the display transparency of the stock model. Okay, let's turn that up to somewhat transparent. So here you can see the stock and the part inside the stock box. Now, you may want to orient the stock in relation to the part. So that's the next item on the list. We'll select Align, and then we're going to go Align Stock. and we're going to align the stock to the bottom of the part, flush to the bottom, and we're going to center in the X and the Y, and we'll pick OK. So here, if we go to the multi-quad viewport, you'll see that we have it aligned flush to the bottom, centered in the X, in the Y. Okay, the next item, if your part wasn't in the correct position, in other words, if you want your world origin to be aligned with a particular point of your part or of your stock, you can use the set world coordinate system to do that automatically. So let's do that. So we're going to, what we're doing in here is we're moving the geometry to a specific point and making that point the world origin. So we're going to set it to the stock box, and then we'll set it to the lowest Z and the southwest corner. So what this is going to do is it's going to actually move the geometry. It's going to move this point over to the world origin. So you see there, everything's shifted over. So now your stock box is at the world origin. Now, if you can leave it like this, and when you zero out your machine, you can zero it out at the bottom left corner of your stock box. Now, if you don't want to have that as your machine origin, you can set it to another location, and you can do that with a work 0. And we're going to set it to the stock box, and let's put it at the southwest top corner. So this is the point. While this is the location of the part, in the CAD file, in the world origin, this is going to be our location for measuring our coordinates, and this will be the 0 point that we're going to use on the machine bed. So let's pick generate, and we'll turn that on. There's the toggles down here. We'll turn on the triad, and this is our work 0, and this is our world origin. And then also you can define a material for your stock. Currently it's set to wood, which is the default, and you can set that to anything you want. Typically this is probably going to be an aluminum part. We'll set it to aluminum 6061 and pick OK. And the material comes into play when you start assigning feeds and speeds for your tools. You can use the internal calculator to help you locate feeds and speeds values based on this material. We'll pick OK there. Okay, we've got our machining setup defined, we have our stock defined, we have a work 0. So now we're going to get into actual machining operations. In the Express configuration, you have 5 2.5 axis operations that you can use. You have facing, pocketing, profiling, engraving, and V-carving. In 3 axis, you have 2 operation types in the Express entry-level configuration. You have a roughing operation, a 3-axis horizontal roughing, or Z-level roughing, and you also have a parallel finishing, and we'll show you both of those in just a second. And you can also drill holes. Now, drilling is not just drilling. You can do a number of drill types, so we'll show you that as well, since we have some holes here. Okay, so let's start off by doing a 3.5 axis horizontal roughing operation to clear the material out of this part. So we're going to pick we're going to pick horizontal roughing operation. We'll pick that from the 3-axis menu, and this is the horizontal roughing dialog. Everything is contained in this dialog that you need to set for the operation. For the control geometry, this will contain the toolpath to a certain area. We don't want it contained. We want everything that the tool can find to remove, to go ahead and remove that. So we don't need to put anything here. For the tool, we'll go ahead and leave it set to 3/8 flat mill. And for the feeds and speeds, we'll go ahead, we have feeds and speeds assigned to our tools already. We'll go ahead and make sure they're loaded from the tool. Clearance plane, we'll leave it set to automatic. And you can see the clearance plane on the screen here. And for the cut transfer, this is where the transfer motions will be performed at, and we'll set that to the clearance plane. So for cut parameters for horizontal roughing, you have a tolerance. And here you can see what the tolerance means in 3 axes. And you have a stock definition. You can leave a certain amount of stock, so we'll leave 25 thousandths. And we're going to do an offset cut pattern, a mixed cut direction. We're going to start on the outside of the part, and we're going to do a step over 25% of the tool diameter. And you can also set cavity pocket regions patterns and core facing regions patterns. For cavity pocket regions, like in here, this is we considered a cavity. Outside would be considered a core. So we'll leave those set to offset on both sides. Okay, so for cut levels, how deep do you want the horizontal roughing to take in each cut level? So we're going to set that to 50% of the tool diameter, and we're not going to contain the tool path in the Z level. We're going to let it cut as much as it can of the stock. So for the engage and retract, we'll leave it set. We'll leave it set to path, since we're going to be entering from the outside, and this is the roughing. And let's just generate this and see what it looks like. Okay, so here, let's go in a multi-viewport here. So here is our roughing operation. Okay, and here you can see the multiple Z levels that are being used. And you can also display each of the levels individually. You can load the Z level display dialog and work through those, and it shows you each cut level. Okay, so let's go ahead and take a look at the cut material simulation for this horizontal roughing operation. So we'll go over to the Simulate tab, and we'll select the operation, and we'll slow this down a little bit, and we'll pick play. Slow that up just a little bit. And let's go ahead and turn the toolpath off so we can see it a little bit better. And we can also, you don't have to wait till all the way to the end. You can pick pause and then to end, and it'll show you the completed cut material simulation. So this is the roughing operation. Now, one thing I do want to point out is that these irregular edges you see here, those are just display artifacts. They're not in your actual G code that you post. And this is due to the fact that in the Express configuration, you have the lower resolution cut material simulation model. In higher configurations, you have a more smoother display as far as the simulating. Okay. So our cut model is a little bit hard to see because the color that we had chosen is similar to the background color. So let's go ahead and change the stock colors. So we'll go into the preferences, stock, and for the cut stock, we'll go ahead and change that. For roughing, we'll go ahead and change that, say, to this color here, and we'll pick OK. So now you see it changed the cut stock to that color. Okay, so let's go ahead and do some parallel finishing on this part. So we'll go to the Program tab. We'll go to 3-axis parallel finishing. And again, we're not going to select anything here. For a tool, we're going to select a, let's select a ball mill. Let's see here. Let's see if we have any. Okay, corner radius mills. We don't have a corner radius. Let's go ahead and create a corner radius mill. We'll set this to 0.375. And corner radius, we'll just leave that. We'll leave everything else the same and just save as a new tool. And we'll go ahead and use the corner radius tool for this operation. Feeds and speeds, we'll load those from the tool. Same clearance plane. Cut parameters, the stock will be 0 since we're doing a finishing operation. We're going to do a mixed cut direction. We're going to start at the bottom, meaning the lowest direction in Y, and then we're going to have a step over of say 10%, And for Z containment, we're not going to contain it. And for entry and exit, we'll go ahead and do a radial entry and exit and a straight linear for the cut connections. Let's generate that. So let's look at the parallel finishing. So here you see it did a parallel finishing operation across the entire part. So let's go ahead and simulate that. And this is parallel finishing. Do a pause and to end. Okay, so it looks like our tool is a little bit large. Let's go ahead and do that with a smaller tool. And we'll set that, instead of 375, let's set that to 1/8. And the corner radius, we'll set that to 0.2. And for the length, we'll do that 3. We'll set that to 1.5. Okay, so let's corner radius mill dash 0.125 diameter. Okay, so let's save that as a new tool. And we'll pick OK. So we're going to use that tool instead, and let's run it. Okay, so you see you got a nice finer step over, and you'll get a bit of surface finish here. Let's go ahead and run that. And we'll pick pause and to end. Okay. Well, even in that color, it's not really clear. So let's go ahead and change that color again. Let's go to stock. We'll do a cut stock. Let's set that to, let's see. Let's set that to this color here. Okay, so that's a little bit better. So here you see your parallel finishing operation. Now in finishing, typically you want to go in one direction and then crosswise to get a good finish. So we're going to make a copy of this operation. We'll paste it. And we'll change the cut direction to 90 degrees and generate. So you see it does the cut direction in 90 degrees from the previous one. So let's go ahead and simulate that. Again, these vertical artifacts are only in the simulation model. They're not shown in the actual cut model, the actual part that you cut. Let's do a pause and then to end. Okay, so now we got horizontal roughing, we got a parallel finishing, and another parallel finishing. Let's go ahead and drill these holes. So let's go ahead and select holes and then pick drill. And for the geometry, we're going to pick select holes on flat areas. And we have a flat area here, there, and there. And it automatically selects the holes. And for a tool, we're going to use a drill. Let's see if we have a drill tool in here. Yes, we do. We're going to use a 1/4 inch drill. Pick OK. And for the feeds and speeds, we'll load those from the tool. The clearance plane, a couple parameters. In drilling, you can do a standard drill. Let's move this over just a little. You can do a standard drill, a deep drill. With deep drilling, you can set a peck increment. You can do a countersink drill if you want to countersink the hole. You can do a break chip, which is similar to a deep drill where you have a step increment, and it actually pulls all the way out and pulls the chips out of the hole. And then we have 4 different user-defined drills, and we'll get into those in another video. So we're going to do a deep drill, and we'll set the increment to 0.1, and we'll start location of cut points. It's at the top of the cut, and we'll set that to 0.5, and we'll add the tooltip, and let's go ahead and generate those. So here is our drilling operation. So let's go ahead and simulate that. It looks like we got our drill bit a little bit big. Let's go ahead and change the drill bit, and we'll change that to a 1/8 inch drill. Okay, and change that there, and we'll generate that. And we'll do a simulate. Okay, there we go. So now we got our part machined, we got it roughed out, we got it finished out, we got holes drilled. So that's it. The basics of machining and the express configuration of VisualMILL. Thank you. Have a good day.